Hello, welcome to your first video of the first unit of chemistry. I know you guys have already watched a video on the growth mindset, and so some of you are probably pretty bored with that. But this is actually the first video that we'll use as far as grading, so you'll get points for this video. All I require is that you take notes and you watch this video. We will be doing this in class so that you kind of get the concept of what I'm talking about. For every video, I always start with a title slide that tells you the title of the section we're going to be looking at. I always will link the readings that are associated with this specific video on that same day on my website. And again, I will show you all of this. This is the very first section of chapter 1. Don't focus too much on the chapter numbers and section numbers because I will go out of order of what the textbook says. So just go off of what I provide for you as far as links. In every single one of my videos, I'll always provide to you an objectives page, and this is just kind of so you know what you're expected to know for at the end of the video. So for this video, you should be able to define chemistry. You should be able to define the difference between macroscopic and microscopic in relation to chemistry, understand the relationship between pure and applied chemistry, identify and describe 5 primary principles of chemistry, and then be able to understand concerns with chemistry in the modern world. Okay, so chemistry defined. So basically, what is chemistry? And so the true definition that I want you to know is that chemistry is the study of the composition of matter and the changes that matter undergoes. And so what that means is that we are dealing with everything that has to do with matter. And if you remember from like 7th grade science, from every single science, matter makes up everything. Matter is anything that has mass and takes up space that can be living or non-living. So we will basically be studying everything that involves in the free world on a macro and microscopic level. So what I mean by macroscopic and microscopic. So macro is the study of large-scale items or things. The true definition, substances and objects that can be seen, touched, and measured directly. So anything that you can see, that you know is there, that you can touch, I can give you a ruler and you can measure it really quickly. Those are all on the macroscopic level. And those are, I would say macroscopic is easier to understand because of the fact that you can actually see it, that you know it's there. In comparison to microscopic, micro meaning small scale, these are small particles that make up all matter. And so a lot of students struggle with the microscopic level because it's hard to see. If I tell you that this desk is made up of trillions and trillions of particles, you're probably thinking, well, yeah, that's great that you told me that, but I can't see it. So how do we know it's true? So that's what we're going to be focusing on in chemistry. We'll be focusing on both the micro and macroscopic levels. So for example, you can see a physical change like something rusting. So iron rusting off a tractor or something like that. And the microscopic level would be what's going on with the oxygen and with the interaction with water. What is that doing to the iron to cause that physical change that you can actually see? So that's a good way to show how microscopic and macroscopic interact with one another in order to show a change on the particle level that then reflects in what you see. Now, how chemistry was established was through the art of alchemy. And so for the reading, I'm not going to go into super detail, but I am going to tell you that the reason why this was all started was because chemists in ancient traditions and ancient times wanted to make things perfect and they wanted to make things into gold. So for example, they wanted to turn like iron into gold, which would be great, right? And if you've ever watched Harry Potter, you've ever heard of the Philosopher's Stone, the Sorcerer's Stone, the Elixir of Life. Those are different words to describe this kind of art of alchemy. It's to make perfection. If you haven't read Harry Potter or haven't seen the movies, I'm a little bit sad right now, but that's okay. Not everybody can be a nerd like me. Anyways, the art of alchemy basically helped establish chemistry because it helped put in order and it helped put consistency to different experiments. It was a way that chemists looked at their experiment and then tried to change things so that they could reach that level of perfection. And although they never were able to make gold out of any products other than having gold, they still helped establish this new art of chemistry. So there are two ways that you can split up chemistry. One is known as pure chemistry and the other is known as applied chemistry. And if you can kind of just look at the words, you may be able to infer how or what that really means. So pure chemistry is concerned with greater understanding of theories behind how matter is changing in chemical reactions. These types of chemists are not truly concerned with how they can apply this to the real world. And so that means that they probably aren't making as much money as those that actually are applying these things to the real world. They really focus on like how something changes or how something works. And so like my old example of rusting on a tractor, they focus on why that is doing what it's doing, not necessarily how we can fix that or use chemistry to fix that kind of issue, but the true concern of how these things work. Now, applied chemistry is just that. It's chemistry that you can apply into the real world. So they basically, applied chemists are directly involved in the application of a different theory. They have a specific goal in mind. They want to achieve that goal. And a lot of times it's driven by money. So a lot of companies will hire applied chemists to help solve a particular problem. And so that's their particular goal, and they figure out how to get the answer to that. There are many times in chemistry where you'll see that pure and applied chemistry will just kind of intermix with one another. So for example, there was a chemist at DuPont, I think that's how you say it, in the 1960s. And they were studying different types of fibers. And so this chemist, and I think her name is Stephanie Kwolek, I think, she discovered this type of fiber that was really nice in helping with the strength of tires. And so she ended up finding that this substance that it never was created before, it was really strong because of the fact that it was made of polymers, which is a really, really long chain of something. And we are actually going to be doing that in the lab. So don't worry. If you don't understand that word right now, you'll know later. But anyways, this polymer was discovered at DuPont and eventually was given the name Kevlar. So she went into this trying to find a new fiber, a different strand of polymer, and then eventually it gets taken and made into Kevlar. And then if you know anything about Kevlar, it's a pretty popular defense substance. It's really strong. So the idea that pure and applied chemistry are two different concepts is there, but they do intermix a lot. And a lot of times, even if the scientist is not interested in applying it, somebody will buy the patent, and then eventually that pure chemistry will be then applied. There are 5 different disciplines of chemistry. We will talk about every single one of these. We will not spend a whole bunch of time on any single one of these topics. Every single one of these classes is a specific class in college. So we're basically putting 5 different classes into one whole year. So we'll be basically touching the surface of all of these. Physical chemistry. So number 1, physical chemistry is the study of both macroscopic and atomic properties and phenomena in chemical systems. So an example of that would be like rates of chemical reactions. So how fast or slow a reaction occurs when you mix 2 substances together. The second type or discipline of chemistry is organic chemistry, the study of carbon-containing chemicals. So pretty much all living organisms are made up of carbon. Carbon is a very, very handy element because of the fact that it has 4 bonds. And so those bonds are able to bond to other substances. And so basically carbon is known as the backbone of life. I took this class in chemistry and went into preterm labor because of how stressful it was. And I'll talk about that story in class. Inorganic chemistry, number 3, is the study of chemicals that do not, in general, contain carbon. So any other element that's not involved in in carbon is known as inorganic chemistry. And analytical chemistry, I did take this class in college too, liked this one a lot more than organic. It's the study of compositions of matter, separating, identifying, and quantifying chemical samples. So basically, in class, we were given a substance. it was made up of more than one type of element. We had to figure out how to separate all that compound, and then tell how much of something we had. And then finally, number 5, the 5th discipline is known as biochemistry. It's the study of chemical processes that occur in living things. And so you're probably thinking, well, organic chemistry is the study of living things. So these two, organic chemistry and biochemistry, are a lot of times closely interrelated. In college, if you are a biology major, you are required to take biochem and organic chemistry. I guess it's not always required, but if you want to go into like med school or anything like that, you do have to take those classes. All right, finally, the good stuff. Where do we see chemistry in our world? And the real answer is we see chemistry everywhere. I've given you a few examples here of how we see them. I'm not going to get into details in this video because I do try and keep these videos at least 15 minutes or less. If you ask biology, I've been making theirs a little bit longer, and I feel really bad about that, but I guess not really. All right, so there are 5 different ways we can see these. We can see chemistry in energy, medicine, materials that we have, the environment, and agriculture. In class, we will talk about these, and I'll give you more examples in detail. So go ahead and leave like a space in between some of these. So like write energy and then maybe like leave 2 lines so that I can give you examples and you have some space to write more. If you have any questions about how we set up the notebook, how to take notes while you're doing the video, we will be watching this video in class. So please don't freak out. You can ask me questions while we are watching the video. I will be walking around and checking on everything. I know that this is new. It's kind of strange. So please feel free to ask questions at the end of this video. Thanks.